First of all, I apologize for my making you trouble. Uh, Now I hope my screen is now shown. Uh, can I continue my talk? Okay. First of all, I apologize for my trouble. I was late sending my video, and I tried to keep my uh, presentation using just my slide, but Varun had helped me to do my presentation alive. So my name is Okuda, and the title of my talk is Add-on of Frontistr to FreeCAD. And so I try to keep my time, but this slide is showing the contents of my talk, starting from introduction. I will show our recent activity to develop the workbench named the frontistr workbench, which is a nonlinear finite element analysis program. And actually, we are rather new guys in the community of FreeCAD, so I'm a little bit nervous how our talk is matching your interest, but I try to present something. Okay. So first of all, just I'd like to introduce what the frontistr is. It is actually the nonlinear finite element analysis program, and this slide shows a brief history of frontistr. Perhaps we have started developing this program from maybe 25 years ago. At the time, Japanese government had started to develop the very large-scale parallel computers called the Earth Simulator, and we joined that that project, and we redesigned the finite element analysis program, which can utilize the data structure which match the vector machines, and continuous short-term project. We have continued developing this program. Sometimes it was ported to the K supercomputer, and right now is a Fugaku supercomputer. But at the same time, we are trying to distribute the outcome of a finite element program to the industrial side, and we have established an non-profit society called Frontistr Commons, and as a part of the activity of Frontistr Commons, we have recently added the frontistr workbench onto the FreeCAD. And so today I just introduce our recent activity. So, and this slide shows some comment about the importance of openness. And perhaps you may have already mentioned about these. So I'd like to skip to explain this slide, but just I'd like to focus on one point, which is that the to share the finite element program is very efficient and important way to keep the transparency. And but as for the input data like mesh physical properties or other database about the materials that can be kept among inside the companies or industries. So that is one important point of the openness or open source code programs. Okay, and this slide shows the very general expression about the CA procedure here. Uh, Not only in the structure analysis, but also in the CFD area, we may start from the modeling and the pre-processing. Pre-processing includes mesh generation and the setting boundary conditions or setting the material parameters. And perhaps afterwards, various kind of finite element programs can be applied. Then afterwards, we visualize the result and evaluate the results. But since the equation, no, finite element solvers are so fast or developed, which are very suitable for the parallel machines, but perhaps over 90 or 95% of the total time may be used in the pre-processing, including the CAD modelings, consumed throughout the CA procedures. And always the pre-post processing is the importance of pre-processing or post-processing is an old and new issues. And we have been looking at various strategies for building all-in-one environment. We may have taken various way, but today, sorry, as we spoken today, we have recently focusing on the FreeCAD capabilities, CAD modeling or its function to extend or to incorporate the workbench from outside. Okay. And also, we are considering these two computational environments. The one is the local use personal computer only, just your local environment. You will do all the CA process. But at the same time, we encounter such environments that when you develop your models, you may use your local machines, and finite element large-scale computations are done in local PC clusters, remote PC clusters or supercomputers. And so we would like to consider these two computational environments. Okay, from now, I'd like to explain how the frontistr, which is a nonlinear finite element structure analysis program, is added on to FreeCAD, or our recent example of this integrated environment. So this slide shows how to install frontistr into the FreeCAD. So we install FreeCAD 0.90 or later, and selecting tools to activate Add-on Manager. and select the FEM frontistr and click install selections, and restart FreeCAD after the installation. So uh, once the installation is done successfully, you can see the add-on workbench named FEM frontistr here. Okay, so and this slide shows how to use. Actually, we in freecad finite element structural analysis program workbench called FEM workbench is already included. So we uh, we may have some help by over the FEM workbench. So at the pre-processing stage, we will create the 3D models using FreeCAD, using part design workbench. And afterwards, we go to the FEM workbench where we will generate the finite element mesh or assign the material constant and the boundary condition settings. Then we activate the switch to the frontistr module here. Then uh, these finite element input data is converted to the frontistr input file, and uh, a binary executable of frontistr is activated by double clicking the button. Okay, and once the parallel computing of frontistr is executed, maybe at the stage of post-processing, you can see the results by using the FEM workbench functions or by outputting the VDK file, and then we can use the open source post-processing tool like the Paraview. Okay. So I will skip this small comment. And also, when we just use a local environment, a CAD model mesh creation, file input, input file export, and loading displays result. They are normally done at the local working directory, but if you are going to run the finite element parallel computation at the remote side, then some related files are sent. And after the structural analysis, output result is sent back, and we can see the result by using the post-processing tools. Okay. And so we have tested some structural analysis case. Even though the frontistr includes various functions, not only in the linear elastic programs, but in this case study, we just assumed the static linear analysis to compare the computational time or speed up of the parallel processing between the frontistr and the calculix. And we have set up these four models, and for each model, we have prepared small, medium, large models. And so you can see the difference of these two finite element programs. Calculate X is the finite element solver included in the FEM workbench, and the frontistr is ours. Okay, and due to the limitation of time, we just look at the Spring model result. So, for the largest case, Calculix computational result is these two bars using using the iterative solver, equation solvers, and the direct solvers. And these right-hand side two bars are the result of the frontistr for the iterative solver and the direct solvers. Okay. So we have learned very much thing throughout the FreeCAD add-on development. So we have learned these 2 points. The forum is very helpful. Also, we have learned that the creation and the publishing the manuals on Media Wiki, etc. Okay. So finally, I'd like to conclude my talk. We have tried to establish the one through computational environment using FreeCAD and frontistr. And still we have many things to do to incorporate the various nonlinear analysis functions of frontistr into the FreeCAD. But we have found that it's very, very helpful and useful tools. And this is the last page. Maybe you can find the various side how to obtain the frontistr, or you can see some video of using FreeCAD with frontistr. Also about the frontistr, you can find the tutorial video here. So please look at these slides later on. So now I'd like to close my talk. Thank you very much. And I'd like to show my great thanks for Barnu to help me or give me a chance to talk.